Have you ever poured hours into a machine learning model, convinced it was a masterpiece, only to see it crumble when faced with new, unseen data? In the exciting world of machine learning, this is a rite of passage for many beginners. But what if I told you that by recognizing a few common traps, you could build more robust and reliable models from the very beginning? In this video, we're diving deep into the most frequent pitfalls for newcomers to machine learning, showing you exactly how to avoid them and accelerate your learning curve. Let's kick things off with the most fundamental mistake of all: practicing bad data habits. The old saying, garbage in, garbage out, has never been more true than in machine learning. You might be tempted to jump straight into model building, but without properly understanding your data, you're building on a foundation of sand. It's crucial to start with exploratory data analysis. Visualize your data distributions with histograms and box plots. Are your features skewed? Do you have outliers that could throw your model off? A simple visualization can reveal stories that raw numbers hide. Furthermore, neglecting to handle missing values is a classic error. Simply dropping rows with missing data might seem easy, but you could be discarding valuable information. Instead, you need a clear strategy, whether it's imputation using the mean, median, or more advanced techniques. Taking the time to clean, explore, and pre-process your data isn't just a preliminary step. It's the most critical part of the entire process. Next, we need to talk about a silent model killer: data leakage. This is a subtle but devastating mistake where information from your test set accidentally contaminates your training set. Imagine a pipeline where a small stream from your unseen test data trickles into your training reservoir, poisoning the well. This can happen in many ways. For instance, if you perform feature scaling or impute missing values on the entire dataset. Before splitting it into training and testing sets, your training process is gaining knowledge about the test data's distribution. Your model will then appear to perform incredibly well during validation, because it has essentially cheated by peeking at the answers. The solution is to enforce a strict quarantine. Always split your data into training and testing sets first. All subsequent pre-processing steps, from scaling to encoding, should be fitted only on the training data and then applied to transform the test data. This separation ensures your model's evaluation is honest and truly reflects its ability to generalize to new, unseen information. Finally, let's address the allure of complexity. It is easy for beginners to get mesmerized by deep neural networks with countless layers and complex architectures, believing that more complexity automatically equals better performance. We often see newcomers throwing a convoluted deep learning model at a problem that could be solved far more efficiently with a simpler approach. Picture this: a massive, tangled neural network struggling to find a straight line on a graph, while a clean, elegant linear regression model next to it draws the line perfectly in a fraction of the time. This is the essence of ignoring simpler solutions. Always start with the basics. Before you build a complex model, establish a simple baseline with something like logistic or linear regression. You'll often be surprised at how well these fundamental models perform. They are also easier to interpret and debug, providing valuable insights into your data. Only increase complexity when you can prove that a simpler model is insufficient for the task at hand. So, there you have it: the pitfalls of poor data practices, the silent threat of data leakage, and the unnecessary trap of overcomplication. Remember, the journey to mastering machine learning is a marathon, not a sprint. Every mistake you make and correct is a crucial stepping stone toward expertise. So keep experimenting, stay curious, and don't be afraid to fail forward. Before you know it, you'll be building powerful, accurate, and truly robust models. Thanks for watching, and happy modeling.